Okay, today's topic is carbohydrates. And carbohydrates, you can just simply say them as hydrated carbon. They consist of three elements: carbon, hydrogen, oxygen, and they have the empirical formula CH2ON. Now you can see the carbon is hydrated with the number of times N. Importance. Now I used a mnemonic here: find rate. Now this, when you think of carbohydrates, you get the idea of energy. You can try to link that with this. Mnemonics, they last longer in your head when you try to link them to the topic that you have it on. So F for framework, I for intermediate. It forms the framework of various skeletons, right? Skeleton, by skeleton I mean cell skeletons. I for intermediate, N for nucleic acid formation, E for energy, R for recognition, A for it's involved in the aging process, T for therapeutics, and E for various other entities. You can also use fine rat if you want, but I would stay with this. Let's go to the chemistry. You're going to find four classifications: mono, di, oligo, and poly. Mono, by the name itself, 1, di means 2, oligo ranges from 3 to 10, and when it is greater than 10, it's poly. Now, things that you need here to know are the families and the optical activity. Family, anomers, epimers, and the optical activity. Now, families. You're going to have two families, D and L. Now here, this carbon atom, so this is just a carbohydrate molecule, this CHOH, this is the terminal group. Terminal group, you can see this is the terminal carbon. The carbon just before that is the penultimate carbon. If the hydroxyl group is placed as such, like here on the right side, this is D. You classify this as part of the D family. If it's on the opposite side, it's the L family. So how can you simply say this? Families are based on the configuration on the penultimate carbon, right? Now let's go to anomers. Anomers, you're going to have alpha and beta. Now for example, think this is a glucose apart. Let's just say just a carbon, right? If the OH is at the bottom, it's termed as alpha. If the OH is at the top, it's termed as beta. So you have, in families you have two classifications, in anomers also you have two classifications. Now let's come to epimers. What are epimers? Epimers are pretty much the same molecule, except for the difference in configuration in one carbon. Like for an example, so if there's a difference of if the OH is placed up and in one molecule at carbon number 4, and in the other molecule if the OH is below at the 4th carbon, then you can say that it's a C4 epimer. Now let's look at the optical activity. Optical activity, you're going to have again two classifications. Now you're going to pass a beam of plain polarized light. It's going to go through the molecule and it's going to rotate. If it rotates towards the right, it's going to be called dextro-rotatory. If it rotates towards the left, it's going to be called levo-rotatory. So you can just say positive, so that is right, or right means positive, right? In the opposite, you can just logically figure that out. So that's that. I believe this will give you a strong foundation in carbohydrates. That's it.